Hello everyone. Today we are going to talk about WhisperS2T. That is an optimized speech-to-text pipeline for the Whisper model that supports multiple inference engines. So Whisper has been out since some time now from OpenAI, and it's generally a very good framework that allow you to do transcription, that is converting speech to text, and allow you also to do translation. And there are heaps of languages over there supported by the Whisper model. However, after the release of Whisper model by OpenAI, several other variants were introduced, like Faster Whisper, WhisperX, and now WhisperS2T. So today we are going to look at how to install this specific library or model locally on your laptop. So I'm not going to use Google Colab or anything else. I'm gonna do it locally on my laptop. My name is Rami Kushaba, and I'll be your presenter for today. So the basic idea of WhisperS2T is that it's generally an open source, let's say, platform or let's say library. It's lightning fast speech to text pipeline tailored for Whisper model. So the authors claim that the speed is it offers a speed enhancements upon the original Whisper and WhisperX. So they say that the speed enhancement is like 1.5 times faster than WhisperX and 2 times faster than the Hugging Face pipeline with flash attention. And it's also in general also like faster than the original OpenAI, and I'll show you that today. WhisperS2T also includes several heuristics to improve transcription accuracies. So let's look at the features deeper. So what are the unique features about this new library, and why do we need yet another library that converts speech to text? So the basic idea over here is that this specific library, WhisperS2T, offers several advantages, including but not limited to the multi-backend support. So it can support the original OpenAI model, the Hugging Face model with flash attention 2, and the C-Translate 2 model. It also allows easy integration with custom VAT models, that is voice activity detection models. So basically these kind of models, in general, they allow you to distinguish the silence from the speech segments and thereby allowing more accuracy in speech recognition. WhisperS2T also offers effortless handling of small or large audio files, so it intelligently batches small speech segments from various files, and also allows streamlined processing for large audio files, so asynchronously load large audio files in the background while transcribing the segment batches. So one of the parameters that we are going to play with today is the batch size, and this is where you can actually specify how many segments of one file are you going to process or of multiple files, and that's where you get some speed advancements basically. Another set of features include, for example, the batching support with multiple language and task decoding, so it decodes multiple languages or performs both transcription and translation. It offers reduction in hallucination, and this is really important because previously I've witnessed myself several examples when I've used WhisperX, where the WhisperX model was actually hallucinating, like just giving me repeated text or something else basically, which didn't exist in the speech. And this is typically when the speech is noisy, or the signal to noise actually level, let's say, plays a crucial role over here. So if you have a lot of noise, expect some sort of weird outputs sometimes. WhisperS2T also offers dynamic time length support, so processes variable length inputs in a given input batch instead of fixed 30 seconds, providing flexibility and saving in computational times. So now we hear about what features does WhisperS2T offer for us. Now let's go ahead and look at how do we install this locally. Again, I'm not going to use Google Colab or anything else. I'm going to do everything locally on my laptop. So my laptop is a Lenovo Legion, and it has a GPU with 6 gig memory. So let's see if we can actually run this specific library on my laptop. So how do I do that? So before you install the actual library itself, there are pre-requirements, or let's say prerequisites, that you need to install. Among which the most important three, I would say, they are the FFmpeg, the NVIDIA CUDA, and the PyTorch. So FFmpeg, if you are not really familiar with this, let's say another library, it's a complete cross-platform solution to record, convert, stream audio and video. So basically, most of these speech-to-text models or libraries, the first step that they do is to downsample the speech signal from the original sampling frequency to typically like 16,000 hertz sample per second, basically. So you need this specific library to do some sort of pre-processing. And sometimes you will also find, let's say, some solutions on YouTube, for example, using WhisperX or WhisperS2T to stitch, let's say, the transcription to the actual video. And this is where you see, for example, word by word transcription. They highlight the word for you if you attach it, like attach the transcription to the video. There are some examples that actually allow you to do word level transcription and highlight the word that the speaker is saying at the specific time. So something like that can also be done with FFmpeg. On the other hand, NVIDIA CUDA is a parallel computing platform and application programming interface. So basically, NVIDIA CUDA is what allows you to run your code on a GPU, but you still need to write your code in a language that can actually use NVIDIA CUDA. And this is where PyTorch comes in. So PyTorch, as you all know, is a machine learning library based on the Torch library, and it allows you to run your code on GPU, basically. So I will stop the presentation over here. Let's actually start the process. So the first thing I'm going to do, I'm going to open an Anaconda prompt. The first thing, I'm going to create a new environment so that I will keep everything in one environment. I don't want to contaminate the other environments, if I have any, with the existing versions, let's say, of the different toolboxes that WhisperS2T will need. So first of all, let me just make sure that what sort of other environments do I have, and if I have WhisperS2T already installed. So conda inv list, this will list all the environments. In this case, because this is new laptop, I just installed Anaconda, and I only have one environment over there, which is the base. So I need to create a new environment to put everything that belongs to WhisperS2T in it. So how am I going to do that? I'm just going to say conda create -n, the environment name, WhisperS2T. I'm going to specify that I need Python version to be 3.10 -y, which means when you get asked the question of yes and no, if you put y over here, it will just bypass that. Before I implement this, let me just go to the internet, basically. Let me go to WhisperS2T GitHub repo. So I just need to make sure of one thing, and that is the version of Python, the 3.10, is actually supported, or if there is a specific version of Python like 3.8, 3.9, if they say something specific that I need to have to install WhisperS2T. So as you can see on the GitHub repo, they give you a lot of instructions of how to install it and use WhisperS2T, which could be by using a Docker container, or you could do the local installation yourself, as I am doing over here. So they give you instructions for Ubuntu, Mac, and Windows, and basically, yeah, all the instructions are there. So I can't see anything specific related to the version of Python, so I'm going to assume that it's safe to use Python version of 3.10. So click enter. Let's create the virtual environment, and then we can start installing everything that we need. So now that the virtual environment has been created, you can see over here it says to activate the environment, all what you need to say is conda activate WhisperS2T. So even that we have created the environment, we are not yet inside that environment, because as you can see over here, it says we are in the base environment. So to actually activate that specific environment, all what you need to do is implement this command. So conda activate WhisperS2T. And now I am inside the WhisperS2T. So from the prerequisites that we mentioned, we said the first and the most important thing to start with is to install the FFmpeg library. So there are a few ways to do that as well. So you can see one typical way is to do it through conda. So you can copy this command and say conda install conda forge FFmpeg, and that will install one version for you. But another approach that we can implement over here, let's go to ffmpeg.org. We click on download. In my case, I'm using Windows. You can select your own version. So I'm going to click on the Windows icon, and then select the XC builds by BTBN, and download the file with the largest size usually. So this is the one created 14 hours ago. Download this. Okay. Seems that I have downloaded one yesterday, so let me take this one, keep one of them. So basically what you do is unzip it. I have 7ZIP, so extract it here. Rename it into FFmpeg, and then cut and put it somewhere else. So you can add it to your environment variables. And in this case, I've placed it over here, FFmpeg, on my C drive. So now I need to go inside this folder, bin, copy the address, and then go to my environment variables. So you go to Advanced System Settings. And by the way, this might look different on your side if you're running Windows 10 or previous versions. I'm running Windows 11, so Advanced System Settings, Environment Variables, you go to the path, you edit, and as you can see, I've already added it over here. So in your case, you will just say new, and you paste it over here. But in my case, I've done that yesterday, okay? So now you should have FFmpeg installed. And if you ask, how do I make sure? Go back to Anaconda prompt, okay? Whether you can do it from the base environment or do you want to activate it first, doesn't matter. So activate WhisperS2T. You can just say FFmpeg just to make sure, and there you go. So you have FFmpeg already installed now, and it can see it basically. So you can see it from within the virtual environment and from outside. So that's the first prerequisite. The second prerequisite, which is the CUDA. So you need to install an NVIDIA CUDA. So if I go back to the WhisperS2T GitHub repo, if I check the requirements, does it mention anything? It says over here that you actually need Torch 2.12 and CUDA 12.1. So one thing you can do over here is that you can clone the repository and then pip install the requirements, but you still need to install the CUDA version, I think, directly. So let's go to NVIDIA CUDA, let's say a 12.1, which I've done yesterday already. 12.1 download. Okay, you select Windows, your architecture. For my case, it's Windows 11, and I'm going to select the local XC, and then you download the file and install it. So this is 3.1 gigabyte that I've downloaded yesterday already, so I won't keep you waiting to download that. So here is the version, CUDA, and I've installed this yesterday. It's very simple. All what you have to do, if you're not really familiar, don't know much about the options, just click next, 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 and that's it. Just follow the commands. It will install for you. Okay? So now it started extracting. It will take a while, but then it will install it if you just press next. You don't want to like bother yourself with the different options over here. Don't worry about it much. So now that we have FFmpeg and NVIDIA CUDA installed, as I said, we need to go and clone the repo. So I have a folder on my C drive, which is called temp. I will clone the repo inside this temp folder. So let's go to this folder. We are inside this folder. So what we do is git clone, and I need the address of the WhisperS2T repo. So paste it, .git. We are now cloning it. Done. We cloned the let's say repo. So dir, that's your WhisperS2T here. So cd WhisperS2T. We are inside this WhisperS2T. So now we can install the requirements. Pip install -r requirements.txt. Requirements.txt. Could not open requirements. Did I spell it wrong? Requirements.txt. Aha, so it started installing, but it complained about the version of Torch and CUDA. So let's do it manually then, because we couldn't do it that way. So now we know that we have FFmpeg, and we know that we have installed CUDA 12.1 ourselves. What we really need to do is to install Torch 2.12. So what I need to do is go to PyTorch, okay, and search the previous versions, because the current version is newer than 2.12. It's like 2.4. So I need 2.1.2. So this is the version that I need. So over here you have options. You can either install it by using the conda command or by using the pip command, the 2.12 with CUDA 12.1. So typically, usually people say don't mix conda and pip, but it still works like if you get the conda version of it and install it. So let me take this command as it is. Come back over here, paste it. Let's install PyTorch. Yes. So now we again just focusing on the installation of the requirements. We haven't yet installed WhisperS2T. Remember that. Okay, this one succeeded, no issues. So we don't have any more problems, I believe. So if we go back to the main page, let's see over here what are the options to install the library itself. So you can do it through the git if you say pip install dot or pip install with the git command. Let me just try this option. Okay. So pip install WhisperS2T is going through it. Has a specific requirement for a version of NumPy. And we should be up and ready very soon. There you go. So now we have everything ready. Now we can start looking at our library, the WhisperS2T. What I'm going to do to you for like today, I'm going to start Anaconda and install Spyder. So the reason why I'm going to install Spyder is that typically, if you're coming from academic background, you typically want to see the code, understand the code, or sometimes put debugging points, like even software engineers, of course, do that. We learn from them. But basically, yeah, if you're coming from MATLAB, let's say, thinking, so the closest thing to MATLAB is Spyder. And it's actually, yeah, allow you to put debugging point, have a look at the code, and do everything you want. So now we are in Anaconda Navigator. So let's look at the existing environments. We created this environment. We installed everything inside the WhisperS2T. So let me log in or go inside this WhisperS2T environment. So now I am inside WhisperS2T. I'm going to install Spyder. So install. And you can do this also from the command line. So you remember the command line? We were at WhisperS2T. I'm doing the same, but using the graphical user interface approach. And I'm installing Spyder from here directly. Okay, so we will wait for this to be ready. And there you go. Spyder has been installed. Now we are going to launch it. Start new code. Okay, and getting back to the GitHub repo. Typically, those guys they put usually a demo of how to call the specific library and the kind of output that you should see. So here's the code. I'm just going to copy it. Control A, Control V, paste it over here. First thing you need to do is to make sure that you have an audio file that we are going to transcribe. So in this case, if I go to my C drive, my temp folder, I have two files that I've downloaded yesterday from YouTube. So there is a way, actually there are so many ways these days where you can download or convert existing YouTube videos into MP3 or MP4. So let me start with the first file that I downloaded from Mike Cohen channel. This is chapter 19. Let me take this, and the address is where C/temp. So what I'm going to do over here is replace this with temp / the file name. Okay. So that's where the file is, and we are ready to test our library. So the first thing we do is to import WhisperS2T, load the model. There are no comments over here. I'd love to see something. So load the model of interest. Okay. Specify some parameters. So in this case, because we said there are, like WhisperS2T supports multiple backends, one of the backends that they put over here is ctranslate2. And the model that we are going to use, I'm not going to download the large V2 because this is like few gigs of data. I'm just going to take the small one, which should do for the purpose of this demo. But typically there are a few of these models. So there's the small, medium, large, large one, and then I think large V2 and V3, large V3. So I'm going to use the small version. Okay, so here I am loading the model. This is where I download the model for the first time from the internet. Then I specify where my file is located on my laptop. What is the language? So I'm going to specify it's an English language. It's usually much faster, or it's better if you specify the language rather than letting the code for the different libraries to figure out the language, like with the original Whisper AI from OpenAI, sorry, because it wastes some time in the beginning trying to figure out what's the language. So to save that time, just tell it it's actually in English. And then we are going to do a transcribe task. So this is where you actually load the model. You say, load the model, and then you test it. You say model.transcribe with VAT, voice activity detection, and you give it the parameters. Now, you remember when we talked about the ability to support multiple portions of one file or different files, the batch we talked about, batch size? Here is where the batch size is actually utilized. So because I'm running on my own laptop, I'm not going with big batch size. Let me start with something small, like 4. And then we can increase it gradually until the code fails for memory issues. So at least let's start with something simple. Let me take everything else. I don't need that. Okay, let's just run it. Let's see if it's going to work. So it fetched a few requirement files. There you go, it's transcribing. So let's see how fast will this process be. So not bad at all. So my laptop has a CPU and a GPU. I'm going to show you the details in a while. So the first time you run it, you get the FFmpeg message for some reason. But yeah, the output is called out. And if I go to out, it's a list. Inside that list, there are a bunch of dictionaries. Each dictionary has a few key and items. So the keys are the actual text. So what's happening here, let me explain it to you. What's happening here, why you have multiple dictionaries, it's actually one dictionary for every segment of time, or portion of time. So the file is chopped into pieces, and for each piece you will get where it did start in time, where it did finish in time. It's like starting time, finishing time, the actual text, and a couple of other parameters like the no speech probability and the average log probability. So no speech probability is very, very low, 0.0000 something. And that's because definitely you have speech. And this is the actual text that we got. Now, how do I make sure that this is actually what has been said? Well, listen to it.
Chapter 19, Data Communication. Section 19.1, What is data communication?
Seems to be working nice.
Well,
so thank you, Mike Cohen. It works very nicely over here. Now we can start doing some interesting things with it. So we got the library up and running. First thing I'm really interested in for my own self, which is I want to see how fast is my GPU. So import time. Okay, I'm going only to benchmark this section. So start equal time.time, end equal time.time. So get the time before we transcribe and the time after. So print an F statement. So we'll say on a new line, time taken for transcription equals end minus start. So we should be ready. I'm not going to save it now. Close this and then run the file. So let's see how much time it's going to take to transcribe this file, MP3 file by Mike Cohen from YouTube. You can bring your own file, but for the purpose of this test, I only prepared 2. So how much time was it? 12 seconds. Interesting. Not bad at all, actually. Now, if I go over here, so Modern Statistics by Mike Cohen.
Chapter 19, Data Communication.
Before that, let's just have a look at 22 minutes and 13 seconds. Okay, is that the total length? 16 actually. 22 minutes and 16 seconds. So let's say 22 times 60 plus 16 seconds. So that's 1336. It took us roughly 12 seconds. 12 divided by 1336 times 100. So that's 0.8 of the recording length. This is how much time it took us to transcribe this audio file on a laptop with a GPU. Very interesting, actually. Very good result, I would say. And it's pretty much fast. Now, few things we need to check, for example. First of all, who says that this is really working on CUDA now or on a GPU device? Well, let's have a look. So this is my GPU, NVIDIA GeForce RTX 4060, if I remember correctly. Yes, 4060. Okay. So minimize it, run the code. Let's see. If it's running here, then this should go up, and it is actually going up. Okay. And is going to finish transcription and go down again. Okay, so it is actually working on a GPU, but there are a few things that we can do over here. Before that, did you notice that the memory didn't get released properly? So the initial amount of memory was that, then You started the library and did the transcription, finished, didn't release. What's going on? Okay, so one thing we can start doing, so we can add few more options. First of all, let me define the parameters of interest. So you know where we said the parameters, specify parameters, that was for transcription. Okay, there are parameters for loading the model as well. So parameters for loading model. So the device should be CUDA. Explicitly telling it to run on CUDA. You can say CPU if you want to test it on a CPU, which we will do that as well. What else do we have over there in terms of the parameters? So we have also there the compute type, type. Okay, this is usually integer 8 or float 32 or float 16, depending on what your device supports, which one of these. Okay, and the last parameter from memory is something that we mentioned before, which was the batch size. So I'm going to put the batch size over here, call it 4, and replace this. Let me just put it there. So that's the batch size. That's the CUDA. Close this. Open that task manager again. Let's review. For some reason, without doing anything, there's some sort of memory already being utilized from the GPU. That's fine, for whatever reason. But let's actually add my parameters over here. So device equal device. And what else did we define? We said the compute type. Compute type equal compute type. Okay, so these are the parameters that we have defined. Go. We're going to see some increase in the memory. It did increase because it loaded the model and is doing the transcription. This is all happening by using our GPU, and it finished the process, but it didn't properly release the memory. Okay, so let's minimize this. Okay, now what we are going to do, we are going to add one more thing, which is import GC, which is garbage collector. And after that, we have run the model and transcribed the file. We are going to say gc.collect. Okay, so that's where you are actually collecting the fragmented memory. And what else do? We need to import torch. So import torch. Okay, take this extra. And we say torch.cuda.empty cache. Okay, and then finally delete the model. So we are doing this so we can release the memory that actually didn't get released properly. Okay, run this again. Okay, close everything, start from scratch again. You should see this is dropping, and it did drop that amount that didn't release. So run the code again. Now we should see it going up and down to the same level after finishing the transcription process. Okay, so it's going to finish in any second, and it didn't release the whole thing again. So we need to take extra steps actually. So theoretically, this should have done something to clear the cache and remove the utilized memory for context. So basically what's going on over here is that NVIDIA CUDA actually retains the model or some memory over here so that it can retain the context basically. and that's why it doesn't release it properly. But there are extra steps that we can do to ensure that it's going to release it for us. So one step that we can start implementing over here is to add a with command. So torch.cuda.device of 0. So we'll do this whole thing under the specified device. Okay, and then you will run the code again and test it again. Okay, close everything, make sure that we are having a clean start, and there you go. So transcribing again, it's happening over there, as you can see the process. And if this doesn't clear it, it did actually drop to the initial level. So by specifying the device, the CUDA device of 0, it actually went to the level it started with. Although theoretically this should be 0, like nothing else is utilizing, but I don't know, maybe something inside Windows is utilizing my GPU right now. So we started with this level, we went up, and then we went down to the same level again. So good, it's actually running on GPU. Okay. Now let's change the audio file and put something bigger and observe how much time did it actually take. So as I said, I had another audio file, and this is from my own YouTube channel for the video of Rocket versus Mini Rocket. So from memory, this is like 40 something minutes. If I'm going to replace this over here, close this, fresh start from scratch. Let's monitor the memory on the GPU as well. Okay, sorry, make it smaller. Run the code. And let's see what's going to happen over here. How much time is it going to take us this time? Pretty much still fast, but not as fast as before, because of course the file is a much bigger size. Okay. It's going to finish very soon. Done. It took 20 seconds. 20 seconds, and let's bring the output. Okay, so we can compare and bring me my own file.
Hello everyone. Today we will be talking about random convolutional kernels for time series classification, also known as Rocket, and the new version of it, which is called Mini Rocket.
That's good. So it's actually very accurate in terms of transcription. Oh, and in terms of time, we could have added something to tell us that programmatically, but overall it's what? 42 minutes 55 seconds. So 42 minutes, 42 times 60 plus 55, and it took us, what did we say, around 20 something. So let's say roughly 21 seconds. 21 divided by 2575 times 100, that's how much it took you as a percentage of the total recording length. So 20 seconds to transcribe 42 minutes of audio. That's really fantastic, actually. It's very good, it's very fast. I'm happy with the performance. Now that we have installed the requirements, installed WhisperS2T, and made sure it's working and the transcription is accurate, I want to try something else. So they say that they support multiple backends. Okay, what if I switch this to the OpenAI backend, again using the small model, keep everything else the same? How much time is it going to take us for this file, which we said it took us like 21 seconds roughly, because it's 20.88. Now that I switch to the original OpenAI, what is the time taken for transcription? Let's answer this question. So I'm going to pause it a bit and come back when it's ready, so I don't want to actually waste your time. As you can see, it actually took us 42 seconds, so nearly double, because the original one, as we said, with the C Translate 2, took us 20.8 seconds, and now using the OpenAI alternative for the same model, which is the small model, it took us what, 42 seconds. Excellent. So we are saving a lot of time just by switching to C Translate 2. So using the same model and the same compute type on a CUDA device and the same batch size. Now, I went back to C Translate 2. I want to see if I increase the batch size, and this is where we said we can do multiple segments of the same audio or different audio files if you want to include more audio on this list. So files is a list, you can chuck more URLs and try to transcribe them. But now what I'm testing is, by increasing the batch size, what can I do over here? Is it going to take me much less time than 20 seconds or 21 seconds that I started with? So remember, I left the OpenAI alone, went back to C Translate, and I increased the batch size. 14. Nice. So again, going back to our benchmark, like base, which was 20 seconds or 21, if you want to consider roughly like 21 seconds. Now we have roughly like, let's say 15 seconds, 14.57, let's say 15, roughly. So it did actually reduce. I can go more and see if my memory will allow that. It might actually fail, tell me this is too much to handle, but I don't know. This is how we actually test, by keep pushing. Oh, it's going through, didn't complain. I wonder how much do we drop it this time? The total transcription time, 13. So not much, but yeah, let's go back and read this. Is it still accurate? Hello everyone, today we'll be talking, yeah, that should be the same, roughly. Okay, so the text is still accurate because the voice quality was actually very good in that video. So yeah, it's doing a good job. Now if I put it back on, let's say 16, this time I'm going to increase the complexity, let's say float 32, and rerun this code. Okay, run. So it's not integer 8 anymore. I changed the parameters, made a batch size of 16 and float 32. So this gives you more accuracy theoretically, but it consumes more in terms of memory because of the number representation over there. It went up to 22 seconds. So for our own application on the file that I've chosen, it doesn't matter much. So I can still switch back to integer 8 because the audio, again, audio quality is very good. But when you have issues with the accuracy, with the word error rates, you can change the compute type and come back here and start playing and see if you get any enhancements, basically. So yeah, this is how we are benchmarking this. And if you go back actually to the WhisperS2T GitHub repo, so the original contributor of WhisperS2T, he did actually a good benchmark against WhisperX, and he showed you the enhancements provided by the WhisperS2T using the C Translate, the Hugging Face with Flash Attention, and the TensorRT LLM backend. So there are different backends, and you can test these and verify yourself. Okay, so yeah, this was the WhisperS2T with the transcription of different file lengths, and we played with the parameters at different backends, and we observed how fast the transcription process was, and we actually measured that. I think there is only one more thing which I can tell you about over here. So another way you can actually transcribe, you know how that issue with the memory where we were seeing some sort of memory not being released? Another thing you can do, instead of defining your Torch CUDA device, is to add a multiprocessing command. So what you can do over here, you can say, for example, from multiprocessing import process. Okay, so I'm going to put this in a function inside the process, and we are going to run it again. So if name equals main. Okay, We say p equal process. Okay, process, and the target is run transcription, and then you go p.start, and p.join. And then we need to do some changes to our code. I'll start by taking this command away. I'm going to define a function. So define run transcription. Right. Make sure everything is under that. Okay. Oh, I need one more equal over there, and we should be up and ready. So now I'm starting the transcription task as a process, separate process. When this process has finished its job, it's completely killed, so the memory is ensured to be released, theoretically. So let's see. Let's run this code again. So rocket versus mini rocket. Now we'll put it back on the Mike Cohen because that was our benchmark example. Okay. Actually, just keep it. Yeah, keep it on the rocket versus mini rocket. Let's see how much time it's going to take. So warning, process may need the file to exist. Which file doesn't exist right now? Oh, I think I know what's going on because we didn't save this file. So save as, let's go to my C drive and my temp, and let's say call WhisperS2T dot, without dot, it will know itself, .py. Okay, now run this again. Yeah, we should be up and running. So it is starting, have utilization for the GPU, and then should drop down to the level it started with when it's finished the process. Okay, so just waiting for that to happen. There you go, finish in 23.2 seconds and went out to the exact level it started with. So yeah, that is another way to do the transcription in a separate process, basically. Okay, so yeah, done. This is what I wanted to show you today. Thank you so much for watching, and I hope you have learned something today.